Today we begin Chapter 4, which deals with congruent figures. If you recall from Chapter 2, we did a lot of proofs, and we're going to start reusing those properties again from that unit. But this time, we're going to use those properties basically to prove polygons, more specifically speaking, triangles are congruent. So you have 5 questions on your paper that basically, it's just a little pop quiz to see if you can guess what the right answers are. So each statement is either always, sometimes, or never. So go ahead and take a couple minutes and see if you can read through the statements and guess what you think, which word fits in those blanks. For the first blank, it says an acute triangle is, this should be never, so I'm just going to put an N for never, congruent to an obtuse triangle. Obviously, congruent means exact same size and shape, so it's not possible for an acute angle to be the same as an obtuse. The second one is always. Something always equals itself. That's kind of more along the lines of just common sense. The third one can be a little tricky. That answer is actually sometimes. So I could draw a right triangle. I can draw another right triangle. They look similar, but they are definitely not the same size, so they are not congruent. The fourth one is sometimes, and we'll kind of talk about that today. And the last one asks about angle B, and that should be sometimes as well. So what is important about congruent figures is they have the same size and shape. So basically, they're replicas of each other. It's like you hit copy and paste on your keyboard. That's what congruent means. They're the exact same size and the exact same shape. Now, that doesn't mean they have to be drawn the exact same way. As long as they can be moved so that they fit exactly on top of each other, no overlapping pieces, no excess pieces, you have 2 congruent shapes. So the first type of movement is called a slide, and that's what you would think. It's when you can slide an object on top of another one. The second type of movement is a flip. So you can see, I imagine if you take this triangle and you kind of fold it over that way, it's going to lay perfectly on the other triangle. And the last figure below is an example of a turn. So your 3 movements are slides, flips, and turns. And as long as you can slide, flip, or turn a shape so that it fits perfectly on top of another, you have congruent shapes. I want to take a minute and talk about the word corresponding. So it's important for us to realize that if 2 polygons are congruent, then all of their corresponding pieces are also congruent. Now, we've talked about corresponding before when we were learning about angles, and I will put angle markings in those 2 spots and ask you, what kind of angles are those? And you would say they're corresponding angles. We're going to learn a different version of corresponding today. Basically, corresponding means if I were to line the shapes up, fit them over top of each other perfectly, what pieces would match up? And we'll see that in an example. I won't go too in depth into it right now. But basically, your sides and angles of a polygon must match up completely after the polygons are flipped, turned, or split. One other note that I want to make known at this point is we'll be writing these things called congruency statements. When you write those, I just want you to keep in mind that order is critical. It is super important that you write your letters in the correct order. If you don't, you're actually going to be writing a false statement, and that's not what we want. So I have a picture of two triangles, and you can see that if I were to flip this triangle, basically flip it over like I was turning a page in a book, it's going to lay perfectly on this triangle. And so we want to kind of figure out, all right, what angle is going to lay on top of angle A? And it's going to be angle E. So we call those corresponding angles. They're angles that would lay on top of each other if I moved the triangle so that they're facing the same way. Likewise, angle B and angle F are corresponding. And angle C will correspond to angle D. So if you notice, a triangle has three angles, so you will have three pairs of corresponding angles. You will also have three pairs of corresponding sides. So I know that side AB, segment AB, will line up with segment EF. Segment AC will line up with segment BE, and segment BC will line up with segment BF. Now, I want to point out, these are all corresponding pieces. Unless I tell you that those two triangles are the exact same size, you can't go ahead and just assume that all these pieces are congruent to one another. I don't have enough information in the picture for you to go ahead and say, oh, well, angle A and angle E have to be the same. Just because they line up on top of each other does not mean they're the same. What we're going to do is we're going to talk about congruency statements. So let's start by defining the word congruency statement. Basically, it's when you have a group of letters, a congruency symbol, and another group of letters. That is a congruency statement. That whole thing put together is what we call a congruency statement. Now, this is where order is critical. Since A and F are both the first letter in their little groups, I know that angle A not only corresponds, but is also congruent to angle F because of this little symbol here. They're telling me that these pentagons are the same size. So from that one congruency statement, I can get a lot of information. I know that angle B and angle G are congruent because they're both the second letter. And we're going to keep going here. Angle C and angle H. So if you do this right, you should count up 1, 2, 3, 4, 5 pairs of congruent corresponding angles, because obviously there's 5 angles in the picture. We can also make some conclusions about the sides. Like, I know that side AB is equal to side FG. The reason I know that is because A and B are the first 2 letters, and F and G are also the first 2 letters. And so I'm going to keep going. And so if you count, we have 1, 2, 3, 4 pairs of congruent sides. But there should be 5 pairs because there's 5 sides in each pentagon. So the side that I am missing would be side AE and side FJ. You are allowed to pair up the first and last letter of each set. Now I do want to point out that when we name a polygon, you can pick any point to start at. So let's say you want to start at D. You have to either go in clockwise or counterclockwise order. You may not skip and go diagonally when you name a polygon. So I can call it either D, E, A, B, C, or D, C, B, A, E. So we can see I can't just pair up C and E. That's not a side in this picture. The only ones that you can pair up that are not beside each other are the first and last letter. So keep that in mind if you ever name a polygon. You have to go around the horn. We're going to turn our attention to congruent triangles because that's pretty much what this entire chapter is about, proving triangles are congruent. So what I want you to notice is the only way I know that these 2 triangles are congruent for now is that they both have 3 sets of tick marks and 3 sets of angle markings. So every angle and every side has a congruent match. That's how I know those triangles are congruent. So what you need to do is write me a congruency statement. This can get tricky. So you draw a little triangle, and let's say you decide to write A, B, C. You need to draw a congruency symbol, another little triangle, but this time you can't just go off and use E, G, and R in any order you want. The order matters. If I look at angle A, it has 2 rainbows. So angle E has to be its mate because it also has 2 rainbows. Angle B is my middle letter. Angle B matches with angle G, so G has to also be the middle letter. And that would leave us with R then as our last letter. And you can see that R and C both have 1 rainbow. They match. That's one way to write your statement. So let's say you wrote this first one on your test, but your friend switched it up and they wrote BAC. Your friends can still get this right as long as they match up their letters accordingly. Angle B goes with angle G, so G would have to go first in this case because B is first. A goes with E, and C goes with R. So this would be an acceptable answer. Say another person decides to write angle CAB. Again, this is fine, you just have to match up your letters accordingly. It'd have to be R, E, G. And we could keep going and making lists, but we're not going to. Okay, so you're going to go ahead and complete 10 through 15. Before we do that, I would like to go through 16 through 19 with you. Let's make sure that you understand what you're doing. If I look at the picture in 16, I really should have right here. So BD is obviously going to equal itself. I will not be putting markings in for you if that happens, so you need to put them in yourself. That is the reflexive property, and we talked about that back in chapter 2. So put those markings in. So I have 3 pairs of angle markings in each triangle. I also have 3 pairs of tick marks. And the reason I gave this 2 tick marks and not 3 is because if these 2 angles are the same, then the 2 sides above them are the same. We'll talk about that later, but I'd like to be correct for right now. So since they can be proved congruent because all the pieces match up, you have to write a congruency statement. That means you have to write triangle BCD. And that's the order I chose to go in. So BCD would have to match up with A, D, B. If I look angle B and angle A, both have one rainbow in them. Angle C and angle D each have a rainbow in them. And angle B up here and angle D down here both have the same amount of rainbows. So that's the statement that I want to use. In number 17, go ahead and put 3 tick marks here because it is the side that's congruent to itself. Now these are actually not congruent. Even though you see tick markings, this side would be, if we let this side be 4, then this one would also have to be 4. That doesn't tell us anything about this other triangle. This could be 6 for all we know, and this side could be 6. So they're not congruent. They have to have 1 tick mark per each triangle, and then 2 tick marks per each triangle. AT is obviously not congruent. We can easily see these triangles are not the same size. And for the last one, you need to put in your own rainbows. That's another one. Any angles that crisscross are vertical, and we learned that vertical angles are congruent. So you will not see markings in those. You have to make them yourself. I see 3 pairs of matching angles. And I also see 3 pairs of matching sides. So therefore, I can write a congruency statement. I chose to do I, J, H. So I would want to either write K, J, L or L, J, K. Since these two angles are the same, you are allowed to switch their places in the order. Go ahead and complete the top part. I'm going to go ahead and write my answers a while without saying anything, and then you can see if you get them right. Go ahead and give your answers a look. Should match what I have. And again, we're strictly going by the ordering of the letters. So again, we can't emphasize enough that order is so critical when we're doing these problems. Keep that in mind because I could give you one statement. From that, you can give me 6 pieces of information. You can give me 3 matching angles and 3 matching sides. That's a lot of information just from one little statement. So next time we're actually going to be taking what we do with this and applying it to our first 2 theorems of proving triangles congruent.